Everybody, we're going to take a look at parallel versus perpendicular lines. When we're talking in the context of the unit that we're in, we're still looking at slope-intercept form when we are dealing with these two types of lines. For parallel lines, the facts that you need to know that the slopes are the same. They have a different y-intercept. Just like some of the problems you saw in class today, where you had the y equals 12x, and then the y equals 12x plus 50. When you graph those, you saw a clear change in the y-intercepts and how they affected the graph, how it got moved up and down. What you also saw was one line going to one slope, and another line going to the same slope, and clearly that they would never intersect. For perpendicular lines, their slopes are opposite reciprocals. The y-intercept doesn't matter for this. It doesn't matter if it's the same, different, or anything. All that matters is the slope are opposite reciprocals. You probably know what the word reciprocal means, like 3/4 reciprocal is 4/3. But to make something opposite would be to change its sign. So an opposite reciprocal would be the negative version of a positive number, where the fraction is flipped, or a positive version of a negative number, where the fraction is flipped. So for example, these two lines would be perpendicular. Notice the y-intercept has no value to the problem other than where it's going to cross the graph. But negative 1/3, if you flip it, is 3 over negative 1. Change the sign, it's positive 3. So let's look at how they would look on a graph. These two are parallel lines because they're the same slope and different y-intercepts. If they had the same y-intercept, it would just be the same line. So you don't really have to think about that when you're dealing with this right now. So for the first line, we would just go down 7 and go up 5, right 1, up 5, right 1, up 5, right 1, and then draw our graph. For the next line, start up at 2, go up 5, right 1, we go down 5, left 1, again, down 5, left 1, and draw our line. And what you'll see are two lines, if I could draw straight lines, that would never intersect and have the same distance all the way through between them because they're never intersect. They have the same slope, they have different y-intercepts. If you think about this as a rate, this one's moving at the same rate as this one, and if they start in different places, they're never going to get to the same place. If there's a runner who starts ahead of you and you run at the same speed as them, as they move forward, you're never going to catch them. So let's look at a perpendicular graph. The slope is 1/2 here, the slope is -2 here. You flip it and change the sign. And that can just be simplified to -2, which is how we got that they're opposite reciprocals. So let's graph this one. Start at -1, go up 1, right 2, down 1, left 2, down 1, left 2, up 1, right 2. Continue our line out either direction. Next line, -2x plus 3, up to 3, down 2, right 1, up 2, left 1, down 2, right 1, up 2, left 1. And again, if I could draw a straight line, you would notice that these two lines intersect at a right angle. And that's the rule about perpendicular lines. And just so you remember, a right angle is a 90-degree angle. It's great for geometry, will come up again in geometry, but for the context of our class, being able to identify, based on the slope and sometimes the y-intercept, whether you have parallel or perpendicular lines.